You might have seen videos on YouTube where people say that you can replace Claude or Claude code with a local model. For some jobs, that is true. Smaller local models can write useful code, search your files, summarize documents, and handle repetitive work privately. But what if you want the kind of open model people are now comparing with Kimi K3? What kind of computer would you actually need to run that locally? A question on X put it very simply. What computer do I need to run the latest Kimi K3 that was released just a few days ago? How many NVIDIA GPUs do I need? Or how many Mac Studios do I need? I also found a Reddit thread asking what hardware would take to run an Opus-class model locally for 100 people. The answers were cut. The answers were all over the place. One person guessed 4 H100 GPUs. Another said 8 B200. Someone else said you would need a rack. So that topic is what we cover in this video. It's July 28th. Kimi K3 weights are public and available to download on Hugging Face. We will do basic memory math and answer 3 questions. Can a Mac Studio run it? Can one NVIDIA server run it? And what changes when 100 people use it? The short answer is that this is much closer to a data center project than a desktop project. And if you watch till end, you will understand the reason behind why. So let's run the memory math. Kimi K3 is a mixture of experts model with massive 2.8 trillion parameters and 1 million token context window. It has 896 experts, but only 16 are active for each token. That reduces the amount of computation needed for each answer. It does not make the other experts disappear. For fast serving, all of those experts still need to be available across the system because the model may choose different experts for the next token. According to official release page, Kimi says the weights use a 4-bit format called MXFP4NE. 4 bits is half a byte per parameter. So the simple math is 2.8 trillion parameters multiplied by half a byte. That gives us about 1.5 terabytes just for the raw weights. That number does not include the extra data used by the 4-bit format. It also doesn't include the inference software, active conversations, or any safety margin. Now, we can answer the laptop question. The largest Mac Studio can be configured with 512 GB of unified memory. That is definitely not enough. Even if someone eventually makes a 2-bit version, the raw weights would still need about 700 GB. The Mac Studio tops out at 512. A Mac Studio can run very useful local models, but it can't hold the full Kimi K3 model in memory. Now let's look at the comment saying 4H100. 4H100 GPUs with 80 GB each give you 320 GB. That is even less memory than the largest Mac Studio. So 4 100S are not enough either. Now, we get back to the first serious server. A DGX B200 or Blackwell chip has 8 B200 GPUs and 1.44 terabytes of total GPU memory. Kimi K3 needs about 1.5 terabytes for the simple 4-bit weight estimate. On paper, that looks almost perfect. In practice, it leaves only about 40 GB. The 4-bit format, runtime memory, context, and serving software all need space, too. So an 8 B200 server reaches the arithmetic floor. I would not call that a practical fast setup. The DGX B300 is more believable. It has 8 B300 GPUs and about 2.3 terabytes of GPU memory. That leaves roughly 900 GB beyond the raw 4-bit weight estimate. One B300 server may be able to load Kimi K3 with useful headroom. We still need the real weights and real benchmarks before claiming how fast it will be. But Kimi's own launch blog points to a much larger setup. For efficient inference, Kimi recommends a super node with 64 or more accelerators. Kimi isn't saying that 64 accelerators are the minimum needed to start the model, but if the company that built K3 recommends 64 for efficient inference, one server is not the full answer. Those are 8 GPU servers. We're talking about at least 8 servers. That isn't a computer under your desk. That's a data center deployment. So, the Reddit thread asked about 100 users, but one comment corrected the question. 100 users is not the same as 100 parallel requests, and that is exactly right. Suppose 100 employees each send one request every 10 minutes, and each answer keeps the system busy for 30 seconds. If the requests arrive evenly, the average is about 5 active requests, not 100. But AI agents can change that quickly. One developer might have several coding jobs running at the same time. The context window matters, too. Kimi K3 supports up to 1 million tokens in one request. That is a maximum. not a normal target for every prompt. Longer prompt and more active requests need more runtime memory and more processing capacity. That is why hardware for 100 users doesn't have one answer. You have to know how many requests are active at our busiest moment, how long the prompts are, and how fast answers need to arrive. The physical setup is easy to underestimate. One DGX B300 takes 10 rack units. NVIDIA lists its power consumption at 14.5 kilowatts. If we used 8 of those servers, the published power figures add up to about 116 kilowatts. That is before cooling and rest of the infrastructure. A person in Reddit thread said their company operates several dozens B200. They described turning them on as sounding like sitting behind an Airbus A380. That's a great personal description. Not a benchmark, but it makes the scale clear. You need high-speed networking, storage, power, and cooling. You also need monitoring and people who can operate the system. And the rental math is large as well. If you simply multiply today's public 8 B200 node prices by 8 nodes, the compute alone lands around $313,000 to $577,000 per month. That is rough scale math. The best answer in the Reddit thread may have come from someone who says they ran an LLM service for thousands of users. They said model's good enough, but that we can scale are better than supermodels for a couple of users. That is probably the practical answer for most companies. A smaller private model may be good enough for document search, extraction, classification, or routine coding work. The hardest request or the hardest task can still go to Claude or GPT. That is what I found on other Reddit thread about people who had already spent thousands on local AI hardware. The common pattern was not fully local. They used local models for private or repetitive work and cloud models for the hardest tasks. Another commenter gave the simplest buying advice. Rent the hardware for a couple of weeks and see whether a few real users like the results. That test tells you more than a benchmark chart. It tells you whether the model can do your work, whether it's fast enough, and how much effort it takes to keep running. So, what would it take to run Kimi K3 locally? A single Mac Studio is not enough for the full Kimi K3 model. 4 H100 are not enough. An 8 GPU B200 reaches the raw weight requirement, but it leaves almost no room for the rest of the system. For efficient Kimi K3 inference, though, Kimi recommends a supernode with 64 or more accelerators. For 100 employees, the final answer depends on how many requests are actually active at once. If this cleared up what running K3 actually costs, subscribe. That is the only thing I am selling here. I will see you in the next one.